Welcome to a lesson with Dr. Powell. Let's take a look at how we can write down the equation of a tangent line given a function. Suppose that we have, for instance, f of x is equal to x times sine x. And we're interested in knowing what the equation of the tangent line is right at x equals pi fourths. How do we do it? Well, we just need an equation that outputs things on the tangent line itself. So let's make a new function, call it L for line. Kind of what we want is, so at x equals pi fourths, we want it to match the actual function here because we want it to be tangent to and match it. So we can say that should be equal to, starting from here, okay, it should share a y value. So when I plug in pi fourths here, I should get out the same thing. But then as I move away, let's see what what needs to happen. On the tangent line, we use dy to mean how much we change from an initial point here from the point of tangency. So to do that, we just take the slope times the run. So the run dx, in this particular case, is how far away we are from pi fourths, to the right or the left, but to the right positive, to the left negative. So we have x minus pi fourths would be the positive negative distance we are, or how much we've changed from pi fourths. That's our run. Then our rise is determined by taking that and multiplying by the slope with the derivative right at pi fourths. So this essentially tells us, so at the point x, what the y value will be of the tangent line. Because we moved from pi fourths to x, so that's our run. We multiplied it by the slope to get the rise, or the change of y on the tangent line from that point. So we end up getting the y value on the tangent line, so we end up getting the equation of the tangent line. So we just have to basically plug in these things and see what it is. Maybe we should take a derivative here. So taking a derivative, we end up getting, using the product rule, 1 times sine x plus x times cosine x. That's the derivative. We can plug in pi fourths, and we end up getting root 2 over 2 plus pi fourths root 2 over 2, or which we could factor out the root 2 over 2 if we wanted to, and get 1 plus pi fourths. Okay, so that's what the derivative is. So here we could just simply write down 1 plus pi fourths times root 2 over 2. Then we have x minus pi fourths. Now let's figure out what f of pi fourths would be. All right, so we just plug in pi fourths into this. We end up getting pi fourths times root 2 over 2. And that right there is the equation of the tangent line. I would just leave it like this. So you could simplify it out perhaps, but really that would be, I think this looks just fine. This kind of signifies where you start when you're at pi fourths, because this part would be 0. And so that's what you would actually end up getting. So the two things would match, it would intersect. And this is just the rise from that point. So we've just come up with the equation of the tangent line. Thanks for watching.